Okay, hello, welcome. I'm Markus from Derivative, and thanks for joining for a little presentation on some of the installations I've been working on recently, or we've been working on with Carsten Nicolai. I'm just coming from an installation that I built up for him. It's the Uni Display installation, and I'll show you what this is all about. But
Добро пожаловать. Да, здравствуйте, меня зовут Маркус, приехал из Дривитева. Будем показывать, посмотрим инсталляции, над которыми работали с Николаем. Yeah?
Okay. We started working with Carsten in 2008, and specifically for the Universe performance with Carsten under his moniker alva, noto. So we'll just play this video.
Начали работать мы над проектом Universe с Карстеном с 2008 года, так что посмотрим на вот это видео.
I guess it's very recognizable, a TouchDesigner setup. And his idea was there to, we talked about working together on a visual set, yet when we were thinking about the visual content, he literally saw the interface and said, let's just use that. And what you can see is that what he's using is very simple translations of audio into graphics. Sometimes just working with the viewers as they are, like our job viewers here. Or a displacement.
« 61, 80, 33, 98, 87, 17, 98, 05, 67, 28, 62, 13, 54, 48, 62, 27. »
And if we look inside TouchDesigner, what actually is behind that, it is a very simple process to create these kind of audio visualizations. So taking an audio input, for example, and you can convert that right away into graphics. Using a chop to chop. So what you see is that literally any amplitude in the audio waveform is translated into a pixel value. And this I could, let's say, I'll just use a text and a displays. And I thought I can do this really quickly. Oh, right, sorry. Border A. This is heavily confusing why this doesn't work. Oh, sorry. Yes. So essentially, that's the basic of the whole setup. If you come. Here in the video, you have a waveform. So you're just offsetting single colors by single frequencies. And there you have the same thing happening.
05, 26, 04, 62, 81, 89, 02, 44, 93, 95, 82, 90, 56, 38, 32, 26.
Now there's a little bit of a secret element to it which we haven't released because we, well, it's not done basically, and this is the moving around in the network itself. So these translations here, where you go from one node to another, there's some old T-script commands that can do that. And a special node which eventually will release when we have enough time to work on it, that lets you do that. And since then, we've gone on and produced a couple other installations. One of them is Uni Display. The video here is from an installation that we've done at Sonar a couple years ago. And it works on the same basic concept. Different visualizations, and you move around, you zoom around them. The whole setup here is a six projector setup, and on each side is large tinfoil mirrors. So you get a really nice endless reflection to each side. Now let's see, I'm just skipping ahead a little bit. If we have a side shot, they have a there you have a view of the mirror to the side. All of these are, again, fairly simple animations. And we'll just have a look inside how that looks when how it looks inside the networks. So here is basically, that's the secret node that we haven't released yet, but it's essentially a network inside a network that you can put onto the screen and that you can control the zoom of. So what I give it is a zoom factor, and I know node positions where certain nodes are located in the network. And using a timer chop, which lets me play almost like a timeline sequence, I control the zoom and position inside the network. And this is essentially the network as it looks when you have 4HD setup. Oh, HD, high definition. Yeah, HD. So yeah, each of these is 760/80 by 1080. There's some interesting problems that we had initially that I'll get to in a second. So yeah, we can just look at some of these components here that are made. For example, the first one is a clock. And the clock displays ratios of time. So you have 2000, 20. 2000, one for the 1 in 16, 2016, so you get the year. 7 July, 1st of July today, and oh. And I guess I'm still on the wrong time here. My time is set to 9:59 a.m. So it's 9:59 seconds and milliseconds. And this is all driven with a clock chop. Whoops, and a couple, yeah, there's no scripting or anything, it's just sub-networks. When copying lines and animating the size of the lines with the chop too. And what do we have here? Right, and the little, the ratios basically here in the back as well. An interesting part is how these numbers are being placed in here. Now, getting numbers to render nicely is a little bit difficult because you get a lot of anti-aliasing, and getting the texture size correct can be a pain. So what I'm actually using here is I'm placing the numbers onto point sprites. So with the control of the scale here, you always get a nicely rendered text. The other thing that we faced was that initially when the installation was developed, it ran on a NVIDIA GeForce 680 with 2 gigabytes of RAM. And the problem that we got then is when you do this at this scale, the renders at the scale that we needed it to be, you would run quickly over the 2 gigabytes. So what we started doing is, excuse me, you have, what you see here is one render, and since the whole installation is black and white, we just rendered or three different visualizations in 3 different colors, RGB.
Вся инсталляция черно-белая, но видите, здесь мы использовали просто 3 разных рендеринга, 3 разных цвета.
So if I use a reorder, I can, for example, just get the clock out. The green channel is a separate clock. And the blue channel is yet a totally different simulation, which is train schedule. This way, you only need 1/3 of the renders, 1/3 of the GPU RAM. Given, of course, that your installation is black and white. This one is a little bit a mess. It's this train schedule here. Let me zoom into it, or let me show you the whole thing. Literally, the task was to get random times, so to say, or random destinations that not a really existing train, but perhaps a train could travel along different stations. So you have here, this line, this horizontal line is the now time. And then you see these little, let me zoom into one. Then you see these little trains here going up these lines. This is basically where a train currently is. So. But as I said, this is all done with or driven by random data. And with a lot of chop working. Which I actually can't explain anymore because I don't know anymore how I did it. You eventually end up with a couple channels that is then again used to with a chop 2 sub. To create the actual geometry for the whole thing. And then the most difficult part, and actually really the part that it still uses T-script and let me find that, is how to determine the position of the trains here. And there you end up with these kind of strange expressions that you could create with T-script. And they can get really long. I'll try to find you a really long one. One second. Oh well. will just go on. But essentially, then again, it creates channels again, which determine position of the train and yeah, in X, Y, and its speed. Others are really, really simple graphics, basically. To get this kind of moire pattern, I just took a pattern shop to create a ramp. And tapered it a little bit to create this kind of curve. And then take a single line, literally, and use instancing and rotate the line. So you create, for this you create 900 copies of the line, and every line is a little bit rotated. Which gives you the nice moire patterns here, or, I mean, the more you zoom in. I'll show you the simplest one here, which is just a line moving up and down. It's kind of also my favorite. So this took me very long to develop. It goes up and down, and that's it. For others, we used, there's also some GLSL in here, and we started kind of trying to make this a magnetic field visualization. And I couldn't do this with instancing. It was just too heavy for using instances. So for this here, I'm using a very small noise top. And feed it into a GLSL mat, which then uses a vertex, but mainly a geometry shader to create or to rotate each of these lines. So again, fairly simple. What came out of it, though, when playing around with it, is yet another shader that creates these grid structures here. It started with the same, almost the same, only here I'm taking a single line noise function. And then feed it into a slightly different geometry shader as well. The benefit for doing this is that I can literally create very, very heavy animated visualizations without losing too much or without using too much GPU power. Can go way heavier than when using instancing. Yet another one, which is actually, I find a little bit It's the sad visualization. There's this sorting simulation here. So, oh. And what we have here is a noise again, which is used to rotate each of these lines between -20 and 20 degrees. And then the task for this whole visualization is, it's gonna reorder, or it's gonna go random in a second again. And now it starts ordering again. So it's a quicksort algorithm that's running through this. And it just keeps sorting, and when it's done, it's being messed up again, and it's got to start over. So that's why I find it a little bit sad. It never finishes. Initially, that was also done in T-script, but eventually I went around and converted it into a Python, just a couple of functions that I can call easier. And I guess that's my little advertising for tomorrow, because tomorrow in the other room I'll be talking a lot about Python and classes, extensions, and all of these kind of things. This one works. It's it's an iterative process. So the functions call themselves again and again. It's a iterative, it's a loop. It's basically a loop, and it calls itself over and over again. And it's the same idea again, using instancing to then rotate them into place. Here's also a very difficult one, that you take a ramp, a circle, and you multiply a copy of it, a flipped copy of it. And you get a large piece out of that. This one's rather interesting here as well. This one deals with modulation. So what we actually have is it's a sine wave that's being modulated by other sine waves. So if you look at this is the initial sine wave that drives it, or it's already the modulated, sorry. This is the initial sine wave here, and this is the modulator on it. Now, depending on what element you add to the sine wave, it sometimes seems that the whole thing is moving, or it seems that the whole thing is a 3D, like a helix. And we'll just wait for the helix. Oh, or if you delete points with this is literally, there's a grid over it which removes points, so to say, like it blocks points, and then it just seems this is actually what's happening, right? The points are just moving up and down. They're not traveling. Yeah, and here you get the helix because of the circles that are placed there, because they are they're rotated and they're scaling. It seems like the whole, or it can seem that the whole thing is actually a 3D object. Now each of these also has an attached sound to it, and initially we were driving the sound inside TouchDesigner. But we found that since early on, we sometimes went below the 30 frames per second that we wanted for this to have. The sound would be kind of warping itself. So for this, we ended up just using OSC and controlling a Max MSP patch that's now in charge of playing the sounds. And because it's a working system, this is still all T-script. I haven't converted this into Python here. After Uni Display, I'll show you a couple pictures actually from the from one of the bigger installations of it in Milan. In Milan, it was at Hangar Bicocca, and I don't remember actually how long it was. It was close to 60 meters or something. Oh. Okay. So after this, what we did with him was Unicolor. That was made for, as it says, the Sapporo International Art Festival, and then shown again in London last year. And as previously, a lot of these visualizations are very simple, but very effective. This one dealing with color. It uses the same idea that it's if every simulation is its own node, and then we're moving and scaling these nodes around. Two mirrors on the side. You might recognize there's a mirror here and there's a mirror here actually. So the installation is not that large, but through the mirrors it becomes huge. What a big difficulty for me was here that we always use the projectors pixel on pixel. They're not blended, so they're stuck up onto each other. And you see, it's very difficult to get two projectors to be the same when you don't have a blend. The biggest difficulty then is that the mirror actually changes the color. So when you look into the mirror, it's different, or the difference between the projectors actually comes out even more. For this one, there's also, it projects onto a, there's actually an upper part here which you can't see because it's really subtle. It's actually projecting onto black velvet material. So yeah, it hides and the other thing is that there's also an LED strip attached underneath the black velvet, which adds a little bit of light that comes down. But it's also hard to see here in the video. And after Uni Color, we did Uni Tape. And that's just from last year in Chemnitz. They did, they asked for Carsten to do this big installation for his 50th birthday. And this deals with patterns that are very close to the jacquard, the textile technique. And so we created these patterns that are constantly moving and partially changing. It's interesting because it also translates right into how music is. And we can have a look at this because that's another one that I actually have here. this one is not animating nodes, but the screen itself is a couple geo components, 3D, and we're scaling and transforming these. And you see again here a time, or so to say, not a time, but a recording head, where the pattern is then via OSC sent to Max MSP, and that translates it to sound. And the basis of this system, there's 3 different types of patterns. One of the patterns is based on the idea that when you take a waveform and repeat it, that you can actually create patterns. Nope, that's the wrong one. Oh. So by me changing the seed, you get a new pattern up here. And I guess I'm recording this. I forgot that I do this. Oh, it's an event. Yes, my favorite node that I forgot about. The event shop is one of those where it's super useful and it's not used much. What it can do is, for every time you trigger it, it actually creates a trigger, like an ADSR. So if I trigger it once, you can see time counting up and an ADSR curve going. But if I keep triggering it, it creates more and more and more of these events. And once they're done, once the ADSR has run through, it's being deleted from the list again. So then every sample you can use in an instancing, for example, to create instances of that event. And that's how these patterns are created. The other way that these patterns are created is actually through Midi files. So Carsten made lots of these Midi files. Which look like this. Or like this. And if you play it back, then you end up with this kind of a pattern. again using the event shop to place the little white nodes. And the third system that creates these patterns is, now I forget the name. But I think you all know it. It's like an automata. Thank you. So it acts on 255 different rules, and it always creates a new, or it sets a 0 or 1 depending on its neighbors. And it does have, yeah, so when you can change it, you change the rule, and it creates a new pattern. Now, I couldn't really figure out how to do this nicely, well, I think I kind of figured out how to do it nicely, but, whoops, we're here. What I ended up doing is I'm running a GLSL script which creates one of the lines. And then I'm flashing the output of that. And convert this to a chop channel, which again is used to create events that are used as with the instancing to actually create the output. And this can, yeah, you have 255 patterns, some of them nicer than others, but enough variety. And you see that we use the same idea with different settings to, yeah, modify the output. For the audio part in this installation, we, now I gotta find it. Where's audio? O2OC. For the audio part, I'm actually grabbing the, because it's a rendered image, and I need to find out what's on this line, like at this time here when it's flowing from top to bottom. So I cropped the image at that point, and then convert it to a chop. And this is then being sent via OSC again to the MaxMSP patch that Nebo, Carsten's assistant, built. In the end, this is what the installation looks like when it's in the overview mode. and all its different modules. So from that, you kind of can see that it's not necessarily the most complex networks that create quite beautiful output. There's a lot of simplicity in it, and often there's not even any much programming, so to say, involved. But a lot of this is actually created just with regular nodes that that are plugged together. And I think that's pretty much it. If there are questions, I'm happy to answer questions. Depends. The Uni Display, I don't really have a time. I can't give you a real number, but couple of weeks, yeah, couple of weeks. And then, I mean, a lot of the work is done on site, where you tweak stuff and make it run fast. It's probably the biggest task always is to get it to run properly and at a constant frame rate. So the initial design is pretty quick, and then the optimization takes the longest. I don't have any other pictures. So that's it? Yeah, okay. Thank you very much.